Hi, we're going to take a look at two things today in the positive and negative intervals of polynomials. So this is just taking a look at when we look at sections on the x-axis, so intervals is what we call them, right? Whether the polynomial function is positive or negative, and what that means is whether the y value essentially of the function when you graph it is above the x-axis or below the x-axis. So those are the things we're going to look at today. I'll explain as we go along. We're going to look first at the positive and negative intervals of polynomials, and then we're going to look at going to look back again on zeros of polynomials and what multiplicity is and how that affects the intervals of polynomials. Okay, so checking out the first one here, we've got a few different types of questions in here, but the first one here that we've been given is we've been already shown the idea that zeros, we already looked at this, the zeros are given by the factors of the polynomial. So you can see here one of your zeros, this negative 6 is given by the factor x plus 6. And the other two here, the negative 6 over 5 is given by the 5x plus 6, so it's the negative 6 over the 5. And the x equals 3 over 2 is given by the factor negative 3 over, 2x minus 3, which is negative 3 over 2, which is what I can see. Okay, so we have these zeros here, and what does that mean first of all, right? So let's take a look at what that means. If we have an x-axis here, let's just draw an x-axis. So let's say we've got an x-axis here, right? This is our x-axis, right? And on our x-axis, we have a couple of zeros. So I'm going to first of all just show our y-axis right here as well, so that we see what's going on. So that we're not going to use it, but so that we see kind of in context. Right, so there's your y-axis. Okay. So we're looking first of all to plot our zeros, right? So we've got a 0 at negative 6, right? So that's going to be let's say this is negative 6 right here. So there's our negative 6. Okay, so there's a 0. We've got a 0 at negative 6 over 5. So that's a little bit over 1. So it's going to be closer to about here. Okay, so I'm going to say that's negative 6 over 5. And then we've got a 0 at 3 over 2, which is about 1.5. So roughly about here, 3 over 2. Okay, so these are our zeros, and we're being asked what is the sign of the function, the polynomial function on the interval negative 6, so between negative 6 and negative 6 over 5. So essentially we're being asked to, what is the sign between here and here, right? This is what we're dealing with here. Okay, so the first thing you need to know about this is the idea of what's happening on the right-hand side of the function. So the right-hand side of the function, is it increasing? Is it going up? Is it going up or is it going down? Well, if it's going up so you're going to look first of all at your leading coefficient. So if your leading coefficient is positive, then your right-hand side of your function is going up. The second thing to know is, of course, is your right-hand side of the function is if it's going down, then your leading coefficient is negative. Now, it also helps to know what's going on with what is actually going on with the function. What's going on with the left-hand side of the function, right? So is the left-hand side of the function the same or different from the right-hand side of the function? So the left-hand side of the function, right, if the degree, all right, hang on. So is it the same as the right-hand side or different from right-hand side, right? right? That's really what we're looking at. Is it also going up or is it going down instead, right? When it's going up, what is it the same or is it different? So the idea here is, right, if your degree is even, then it's going to do the same thing as the right-hand side. If the degree is odd, then it's going to do a different thing from the right-hand side. So let's take a look at this polynomial here, right? Okay, because that's all we got to look at here. Well, when we multiply out this polynomial here, look at your leading coefficient in every, or your leading term in each binomial. Okay, so these essentially are going to give you your leading coefficient when you multiply them together. So you're going to get 2x times 5x, and so you're going to get 10x cubed is going to be your leading coefficient, right? We could multiply this whole thing out if you want and check it out and test it if you like. So this gives us all the information we need. We see that it's an odd degree, and we see that the leading coefficient is positive, right? And that's all we need to know. So what that tells us, right? What that tells us, at least for the beginning, is the right-hand side of the function is going up. So we have a function. We've the right-hand side of the function here, and it goes upwards, right? We also know that our degree is odd. That our degree is odd, so our left-hand side of the function goes downwards. Okay. Now, that's not quite enough, because the other part of this is that we need to look at, and we're going to look at this more in the second skill set, right? Is if there are any repetitions. Okay, there's no repetitions here, so there being no repetitions here, right? Of factors, no factors repeated, so no zeros repeated. Okay, that means that it's going to go through every time. So it's going to go through here. It's going to turn around somewhere, we don't know where, right? It's going to turn around again, and it's going to go like this, right? So between -6 and -5, we know that it's going to be positive on the interval, okay? All right, so we know it's going to be positive on the interval. And this is just within that interval that we're talking about. There's various other intervals that we're looking at as well. Okay, let's check a few other questions before we move on. Okay, so I'm just going to clean this up because there's a few things I want to use again, and I don't want to take up your time by rewriting them out. Okay, so I'm going to get rid of that and a few other things in here as well. I'm going to try and keep my there we go, tidy this up. Okay. So now what we have here is we've got a different interval, we've got different zeros, different function. Let's take a look at what's going on here, okay? So we've got but we have the same rules, okay? And that's what's essential here, the same rules, okay? So let's look at, first of all, what our zeros are. So here's all our zeros, right? We've got a 0, -5, -4, 1, and 2. So let's go with, put -5 down here. This is -5. This is going to be -4. This is going to be roughly 1 and roughly 2, right? I'm not too concerned about exactly where they are, but so long as I've got them there, right? So we've got zeros at -5, -4, 1, 2, and we've got one at 9 as well. So that's actually, we've got our scale kind of wrong, but let's put it up here. The scale's wrong, but it'll still work. It's okay. And we're specifically looking at the interval -4 to 1. So we're looking right here. Okay, so we're looking at the interval 4 to 1. So this is going to be either positive or negative to start, right? Because if there's any cross through, we're not actually showing anything with cross through, so we should be fine with that. It's going to be either positive or negative, okay? All right, so let's look at what's going on with this function, right? This function here, if we multiply all of the leading coefficients, or the leading terms of the factors, right? We've got 1, 2, 3, 4, 5 x's. They're all positive, so x, and there's no coefficient, so it's x to the 5, right? So it's a positive leading coefficient. It's 1x to the 5, if you like, and it's an odd degree. So positive leading coefficient and an odd degree. Okay, so positive means that up here it's going to go up, and down here it's going to go down. Right? That's the key idea here. The other thing here is that we've got no repetition. Right? We've got -2. We got a 2 with a -2. We got a 4. We got a 5. We got a -1 and a 9. Right? And the other thing to check here is they all match up. So there's a 0. There's 1, 2, 3, 4, 5. So they all match up. Okay. So all of these match up. We got the same number of zeros as we have factors, and so everything goes through, like I said. Okay, so our function looks something like this. We really don't care exactly about getting this exact, but it looks something like that. Okay, and we of course are concerned with this area right here between -4 and -1, and so we've got our function is negative. It's below the x-axis on the interval. Okay, so that's what we're looking at here. Okay, let's look at one more. Okay, looking at one more, again, cleaning it up here so that we can use this stuff again. There we go. There's our x-axis and our y-axis all set, and we're ready to go with this. Okay, so looking at this one here, okay, let's create our zeros. Get our zeros in here. We got one at -3. Oh, it looks like I'll use that again. So we got one at -3. So let's say that's a -3 right there. All that really matters is we get them in the right order. -5/2. Well, that's the same as about 2. That's 2.5. So it's roughly here. Let's say that's here. We know it's -5/2. Right. So that's about 2.5. We got 10/3, which is 3 and 3 1/3. So this is 10/3. We're going to use this one here, 10/3. And we've got 4, so 3 1/3, 4 comes after that. Okay, so really the scale doesn't matter, just that we have them in the right order. That's what matters. And we've got 4 zeros match up with our 4 coefficients, so that is all good. We look at our leading coefficients here for our factors. We see that it's all positive. Okay, so we have 2 times 3 times 2, that's 12. And we've got 4 x's, so it's 12x to the 4. So we've got a positive leading coefficient and an even degree, okay? So that means on this side it's going to go up, and on this side it's going to go up. Those are our two sides, and we see here that it's going to cross over, it's going to cross over again, cross over again, cross over again, and it's going to look roughly something like that. Obviously not as messy as that, but this is roughly what it looks like. And we're assessing between -5/2, which is this part right here, and 4, which is this part right here. Okay, so we can see here sometimes it's positive, sometimes it's negative, and that's what we got going on the interval right there. Okay, so moving on to multiplicity. So this is closely related, and this is something very different that happens. Okay, so what you're looking at here, once again, you're looking at your zeros. Okay, so once we look at the zeros of the polynomials, we see we've got a 0 here. I wanted to use a different color here. We got a 0 here, we got a 0 here, and we have a 0 here. But notice it's not crossing over here. Okay, what's actually happening here is it's bouncing off the axis. And when something bounces off the axis, it has 2 zeros at that point. Or it has an even number of zeros. So the idea here is if it crosses through, the 0, then it has an odd exponent. So that means an odd exponent, right, on the 0, right? And then if it bounces off the 0, then it has an even exponent. And what we say is that it has a multiplicity. So the exponent is the multiplicity on that factor, and this is on the factor, right? factor. Right, so we say the factor happens twice. So this is something that you see when you're looking at your quadratics. You might see a quadratic that, for example, has, I don't know, x plus 2 squared, right? Okay, so x plus 2 squared is a factor of a quadratic, right? Okay, and that this is a quadratic that has a multiplicity of 2, and what it means that it has is that at the 0 of negative 2, right? At negative 2, so it has a 0 at negative 2, but it bounces. Right? So there's 2 of them. So there's actually 2 zeros right here. Or more specifically, there's an even number of zeros. Okay. So what could be? I mean, we're talking about what could be the equation of this polynomial. We're not 100% sure because we could have a higher degree on each of these. It could have 3 zeros at negative 3, for example. Unlikely, but because of how it goes straight through rather than kind of almost bouncing off it twice, kind of thing. Well, you see those characteristics later when we talk about those later. Okay, but essentially here, what we're looking at is we've got a 0 at negative 3, which means we've got a potential factor of x plus 3. We've got a 0 at negative, this one here is negative 1/2, so that's a factor of 2x plus 1. And then we've got 2 zeros right here, so we've got a factor of x minus 3 that occurs twice. Okay, so this is what we're looking for in our factored polynomial. So what could be, and this is what you're going to be asked, what could be the equation? And so we're just matching it up with what we've got. X minus 3 squared, x plus 3, 2x plus 1. There's our first one right there that we're looking for. Right? So that's the one we're looking for, and this is the reason why, because it bounces off the axis, and so that's why it creates a multiplicity of an even number. And they say what could be it could be a higher exponent, but in general we're just dealing with multiplicities of 2 right now. So what we say is that we have that the zeros of this polynomial, right? That the zeros we say the zeros are negative 3, negative 1/2, and 3 with a multiplicity of 2, right? So that's how we write that. We got negative 3, negative 1/2, and 3 with a multiplicity of 2. Let's look at another example. Okay. All right, so looking at this polynomial here, same kind of questions, right? We're looking at this here is a 0 of negative 3 with a multiplicity of 2. This is 0 of just negative 1, right? And this is a 0 of 2 with a multiplicity of 2, right? And so we can factor this out as, right, we've got negative 3, so our factor is going to be x plus 3 with a multiplicity of 2. We've got x plus 1, and then we've got x minus 2 with a multiplicity of 2. So this is what it looks like, okay? So those are the factors we're looking at. So it's the same idea. The zeros just correspond with our factors, but when we bounce, when we bounce off the axis, we create an even multiplicity. So we create a second factor at those points. All right, so we should have this one looks like this one right down here is what we're looking at. X plus 3 squared, x minus 2 squared, x plus 1 is what we're looking at. I'll do one more. Of course, obviously, if you get this idea, feel free to stop the video and go working on something else. And this is something that kind of this goes a little bit more in depth with our multiplicities, right? So the idea that this kind of slides before going through means that it has a multiplicity. It actually has a multiplicity, that is not 1. It's not going straight through. Okay, so this is where multiplicity still come in. This one here is pretty straightforward. It's just bouncing right off. Okay, this is just bouncing right off. So we could say that it has a factor. It has a 0 of 0 with a multiplicity of 2. Right, so that's a 0 of 0 with a multiplicity of 2. But this one here has a 0 of 2 with a multiplicity of 3. Okay, and I say that as multiplicity of 3 because it's not going straight through. If it was going straight through, that would be a multiplicity of 1. But because it's sliding off of it and it's creating a curve, right? It's creating a cubic curve right here, right? Therefore, it has a multiplicity. So we would say that the factors of this would be, well, we could write this as x plus 0 if we wish, with a multiplicity of 2, and then x minus 2 with a multiplicity of 3. Just recall that this first factor is not generally written like that, so therefore we would say that this would be x squared times x minus 2 with a multiplicity of 3. And so same kind of idea, except since we're sliding off of it, we've got to increase the exponent, so it's a multiplicity of 3 instead of 2. And so we're looking at this one right here. Okay, I think you have enough to go by for the lesson. If you've got any questions, please feel free to leave them in the comments.